Morning, class. How are you today? So, how did you find our lesson last meeting? Let's have a quick review on force and motion. So, a force is simply a push and a pull. All forces have both size and direction. So, when we say balance force, a net force on an object equals 0. So it means it does not produce change in motion, while unbalanced force, when a net force of an object is not 0, and this produces motion. So class, I hope it is clear now. So today, join with me and let us explore more on force and motion. Okay, so take a look on this picture and also the given situation. Okay, so what do you think will be your motion when a sudden brake applied on a running car? Okay, the next is, what do you experience when a bus moves quickly from rest? Then, what happens when you shake a branch or a tree? Now, try to look at this. So as you can see, there is a 3 cars. Of course, it is very evident that the speed of the car running too fast. So the quicker one turns, the greater acceleration. Okay. So what do you think will be our lesson for today? Wow, the 3 laws of motion. But first, we have to read our learning objectives. So, define the 3 Newton's law of motion. Next, describe how do the 3 Newton's law of motion differ from one another. Then discuss the relationship among force, mass, and acceleration. Then appreciate and value the importance of the laws, especially in what situation we can take advantage of our understanding of this law. Okay, class. Now, who discovered these laws of motion? So I hope you know this man who is very much familiar with his discoveries. So he is Isaac Newton. So Sir Isaac Newton, an English scientist and mathematician famous for his discovery, which is the 3 laws of motion. So he described the motion of all objects on the scale we experience in our everyday lives. So as he quote, if I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. So that was the word of Isaac Newton. Okay, now try to look at these pictures. So what you have to do is predict what would happen to these 3 vehicles and explain your observation based on the given situation. Okay, so the situation goes like this. Consider a ladder placed and strapped at the top of a moving truck. So when a driver suddenly slams on the brake, which car would you likely to be in danger of a falling ladder? Okay, so the question is it in front or is it at the back of the truck? So explain your answer by filling out the first column of the table on the next slide, and do not answer the last 2 columns for yet, as those will be filled out at a later time when you are done with the first 2 columns or when we are done with our discussion. Okay. So you have here the sample table. So try to follow the instructions. Now, we have here the Newton's first law, or the law of inertia. So it states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by unbalanced force. So what does it mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. Okay, try to see this illustration. An object will not change its motion unless acted on by an unbalanced force. If it is at rest, then the object will stay at rest. If it is in motion, then it will remain at the same velocity. Okay, so try to look at this figure. Objects with a greater mass have more inertia. It takes more force to change their motion. So if you can see, it takes force to change the motion of an object. Okay, so try to look at it. Try to figure out that the book is on top of the table. So the table pushes upward on the book. The gravity pulls downward on the book. So if the forces of an object are equal and opposite, they are balanced, and the object experiences no change in motion. So they are not equal and opposite, then the forces are unbalanced. So motion of the object changes. Okay, so we have here another example. As you can see, at figure 1, the ball is at rest. At figure 2, okay, someone kicking the ball. And figure 3, the ball is now in motion. So, a soccer ball is sitting at rest. That is in figure 1. It takes an unbalanced force of a kick to change its motion. So as you can see, the moment you kick the ball, then there is already a motion. So the kick on the ball, the motion is also towards on the direction of the force applied by the one who kicked the ball. So we have here another example. Okay, so there are two teams playing tug of war. So both teams are exerting equal force on the rope, but in opposite direction. So this is also an example of balanced force. So the result of this, there is no change in motion since they are applying an equal force. Okay, class, I hope it is clear. Now, we have another example for the law of inertia. So, why was it so difficult to stop the Titanic from colliding with the icebergs? Now, you have to consider that the mass of the Titanic is very large. So, the Titanic could not change its direction because it is extremely high inertia, forces it to continue in a straight line. So therefore, colliding with the icebergs. So you always have to remember that the inertia is proportionate to the mass. So if an object in motion tends to stay in motion, why don't moving object keep moving forever? So that would be your question. Okay. Why? Things don't keep moving forever because there is almost always an unbalanced force acting upon it. So if you try a book sliding across a table, it slows down and stops. That is because of the force of friction. Friction can slow down the motion of an object. Okay, if you throw a ball upward, it will eventually slow down and fall because of the force of gravity. Now, try to look at this picture. So as you can see, the more mass has the object, the greater the inertia. The smaller mass, the lesser the inertia. So the smaller mass, the less energy applied. The higher mass, then you need a greater energy for that object to move. Okay, so the first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to change its motion. Okay, now maybe we will ask, what is the relationship between mass and inertia? Okay, so the relationship between mass and inertia is the inertia of an object is directly proportional to its mass. Or the greater the mass, the greater the inertia. And the lower the mass, the lower the inertia. Okay, so is inertia a force? No, inertia is not a force, but inertia is a property of matter. Inertia does not act on something, but it is the force that acts on something or makes an object move. So, now, since we are done examining Newton's first law of motion, then we will try to move on to the second law, which is the law of acceleration. So if the first law, we look at how moving and stationary objects behave in the absence of external force. In the second law of motion, we will study at how force as well as the object's mass can influence the movement of an object. Okay, so let's begin by studying the situation. So as you can see, you have here a same person pushing a cart with the same mass, but try to look at the force they applied. So the first figure, or figure 1, tells us that the force applied by the man on the cart is lesser, then therefore, as you can see, that the acceleration is also less. So less force applied, then less acceleration. Okay, so as you can see on the second picture, or on the second figure, that the more force you applied, then the more acceleration. So when there is more acceleration, then of course the speed increases at the same time. So if you apply more force to an object, then therefore it accelerates on a higher rate. So again, class, the law of acceleration. The more force you apply, then the more acceleration and the speed increases. So lesser force applied to an object, then therefore you have to expect lesser acceleration, and the speed also is decreased. Okay. So what does the second law of acceleration state? So if an object is direct proportional to the net of force acting on it and inversely proportional to its mass. So remember that acceleration is a measurement of how quickly an object is changing speed. Okay, so you have here an activity. So try to look at the picture and also try to read and understand the situation. So a dump truck and a Honda Civic. So suppose a dump truck collide head-on a Honda Civic. Which vehicle would undergo greater change in its motion and why? So write your prediction and explanation in the before column. Then later, substantiate your answer for the after column with the help of the set of texts and videos that follows and also right after our discussion. Okay. So you have here another activity. So try to predict which car finish line first. Is it the loaded or is it the unloaded? So try to observe. So how did the additional load on the first car affect its movement? Then, how can you see the result of this demonstration to explain the dump truck versus the Honda Civic? So I hope it is clear. Now, let us proceed to the example of acceleration. So try to look at this illustration. So an object accelerates relative to the force applied and in the direction of the force. Okay. So as you can see on the first illustration that the greater force applied has greater acceleration. And next, lesser force applied, then of course lesser acceleration. And the slower force applied, then you can expect a lesser or slow in acceleration. So the greater force applied, the greater the distance traveled and the higher speed achieved. So try to understand the situation and the law of acceleration. The greater force applied, the greater the distance traveled, and the higher speed achieved. Now, forces are unbalanced, and when it is unbalanced, then therefore it produces acceleration. So once it produces an acceleration, then the acceleration depends directly upon the net force. As what I have said earlier, if the net force is lesser, then the acceleration of that object is also less. Okay, so the acceleration depends directly upon the network, and the acceleration depends inversely upon the object's mass. So again, the greater the mass, the greater the force you need to exert for that object to be in motion. So I hope you got it. Now, the big equation for the law of acceleration. So Newton's second law of motion can be formally stated as follows. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force and the same direction as the net force and inversely proportional to the mass of the object. So always try to remember that the mass of an object depends on the net force that you are going to apply. Okay, so this verbal statement can be expressed in equation form as follows. Acceleration is equal to the net force over mass. So the above equation is often rearranged to a more familiar form as shown below. So the net force is equated to the product of the times the acceleration. Okay. So net force is equal to mass times acceleration. So in this entire discussion, the emphasis has been on the net force. So always try to get the net force. So the acceleration is directly proportional to the net force. So the net force equals mass times acceleration. The acceleration in the same direction as the net force on acceleration is produced by a net force. Okay. So, remember, 1 Newton is equal to 1 kilogram times mass squared. So, the definition of the standard metric unit of force is stated by the above equation. 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 Okay, so we have here some exercises for you to do. So you can go over this after our discussion. Okay. So again, the force applied on a body is proportional to its mass and acceleration produced. In other words, small force, small acceleration. So, what will happen if you push twice as hard? So, if you push twice as hard, it accelerates twice as much. So, the more force you apply, then the greater the acceleration it gives you. So, but there is also a twist. So, always try to look at in every situation for the twist. So acceleration says that it is inversely related to the mass of the object. So force with greater mass, then small acceleration. Then force with lesser mass, then you have a large acceleration or greater acceleration. So that is the twist. So okay, we have here some problem. Okay, we will try to solve this one. So like any other quantity, force has a unit and is expressed in Newton. So 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 per second squared. Or 1 Newton is equal to 1 kilogram mass second squared. Now, suppose a ball of mass of 0.60 kilogram is hit with a force of 12 Newton. So, what do you think will be its acceleration? Okay, so the equation would be acceleration is equal to net force over mass. So you have to substitute the value of the net force. So the value of the net force is equal to 12 Newton over 0.60 kilogram. That is the mass of the ball. Then the acceleration would be 20 per second squared. So If the force is increased to 24 Newton for the same ball or object used or the mass used, then you have to substitute the value for net force that is equal to 24 Newton. Same, since they use the same ball, then the mass of the ball is 0.6 kilogram, then the answer would be 40 squared. So I hope it is clear. This is a simple equation. So again, balance force causes no acceleration, and unbalanced force, the net force is not equal to 0. Okay, so in summary, the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. So Newton's second law of motion pertains to the behavior or object for which all existing forces are not balanced. So when you say not balanced, then therefore the net force is not 0. So the second law states that the acceleration depends on two variables, the net force acting upon the object and the mass of an object. So the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. So as the force acting upon an object is increased, the acceleration of the object is decreased. Okay, so I hope it is clear. Now, we will proceed to the third law of motion, so which is the law of interaction. So it says that for every action, there is always an equal and opposite direction. Again, law of interaction, it says that for every action, there is an equal and opposite reaction. Now, how it is, or what does it mean? Try to look at this figure. For every force acting on an object, there is an equal force acting in the opposite direction. So right now, gravity is pulling you down in your seat, but Newton's third law says that your seat is pushing up against you with equal force. So this is why you are not moving. There is a balanced force acting on you, gravity pulling down, then your seat pushing you up. Okay, so class, think about it. What happens if you are standing on a skateboard or a slippery floor and push against a wall? You slide in the opposite direction. That is away from the wall, because you push on the wall, but the wall push back on you with equal and opposite force. Another, why does it hurt so much when you stub your toe? So when your toe exerts a force on a rock, the rock exerts an equal force back on your toe. So the harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe will be hurt, and the more pain you can experience. So it is just the action-reaction. So again, the third law, there are two forces resulting from this interaction. and a force on the chair and a force on your body. So these two forces are called the action and reaction forces. So force and interaction. So as you can see, the man pushes the wall and the wall pushes back the man. So there is always an equal but in an opposite reaction. So right after the action, you can also feel the reaction. Another example. So flying gracefully through the air is the bird. So the bird depends on Newton's third law of motion. As the bird pushes down on the air with their wings, the air pushes their wings up and gives them a lift. So again, the action-reaction force. Okay, we have here another. The reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine producing hot gases. So the hot gases push against the inside tube of the rocket and escape out the bottom of the tube. As the gases move downward, then the rocket moves in an opposite direction. Okay, so the difference between the forces related to the law of interaction and forces in a balanced state are as follows. So for the action-reaction forces, the forces are equal in size, and in balanced force, two forces are equal in size. Then action-reaction, two forces are opposite to each other. Then two forces are opposite to each other in terms of direction, that is under the balance force. Then two forces have the same line of action. Then action acts on one object while reaction acts on another object. So class, I hope it is clear now that the law of interaction, there are two forces involved, which is the action and the reaction forces. So that is how rocket works. Okay, so I have here some situation about action and reaction pair. So what you're going to do is to identify which one is the action and which one is the reaction. Okay, so tires, when an when action is A, exert force, and B, the reaction is simply B exert force on A. Now, tire pushes the road and the road pushes the tire. So which one is the action here? So of course, the action here is the tire pushes the road and the reaction is the road pushes the tire. Okay, next. We have here the rocket pushes gas and gas pushes rocket. Now, which one is the action and which one is the reaction? So, the action here is the rocket that pushes the gas and the reaction is the gas pushes the rocket. Then another one is earth pulls the ball, then the ball pulls the earth. So, which one is the action? So the action here is earth pulls the ball, then the reaction is the ball pulls the earth. So I hope this can help you in identifying action and reaction pairs. Then that is an example for the law of interaction, which is the third law of motion. So I hope it is clear, class, that about the three laws of motion and how they are being used. So again, the Newton's third law describes the relationship between two forces in an interaction. So one force is called the action force and the other force is called the reaction force. So neither force exists without the other. So they are equal in strength and opposite in direction. They occur at the same time, simultaneously. Action, may reaction agad. So class, I hope it is clear with you. So now we are done with the first law, which is the inertia. Then the second law, which is the law of acceleration, which express that force is equal to mass and acceleration. Then we have the third law, equal and opposite reaction. So action, reaction, forces. The force is equal but in opposite direction. So class, I hope you can now simply describe and explain the difference among the three laws of motion. So class, I hope everything is clear for the three laws of motion. And I'm sure you can differentiate, then explain the difference between these three laws of motion. Or you can simply describe how the law of inertia and law of acceleration and the law of interaction. And of course, how would you apply this in real life situation? That the motion of an object depends on the force. So it is very much helpful since we are moving always in our daily lives. So force in motion is very much important. So we must have to take advantage on how force in motion really affects us. So thank you and have a wonderful morning. So God bless and see you next